Hi all, welcome to Kinetic Theory of Gases. In this chapter, we will learn the macroscopic and microscopic properties of gas. The Boyles Law, Charles Law, Pressure Law, and the ideal gas equation are used to describe the macroscopic properties of gas. The root mean square speed of the gas molecules is used to explain the microscopic properties of gas. What is meant by an ideal gas? It obeys gas laws like Boyles Law, Charles Law, and pressure or Gay-Lussac's law. Define these three gases law. Let us start with Boyles Law. The pressure of a fixed mass of gas at constant temperature is inversely proportional to its volume. Where PV equals to constant, and mathematically P1 V1 equals to P2 V2, or P initial V initial equals to P final and V final. How about Charles' law? The volume of a fixed mass of gas at constant pressure is directly proportional to its absolute temperature. V and T in the reciprocal shape. So V over T equals to constant. Mathematically, V1 over T1 equals to V2 over T2, or V initial over T initial equals to V final over T final. V is volume and T is absolute temperature. And finally, Gay-Lussac's law or pressure law. The pressure of a fixed mass of gas at constant volume is directly proportional to its absolute temperature. Where P over T is equals to constant, mathematically P1 over T1 equals to P2 over T2, or P initial over T initial equals to P final over T final. P is the pressure and T is the absolute temperature. And now, what is meant by an absolute temperature? Absolute temperature is the temperature measured using the Kelvin scale, where 0 is absolute zero. The 0 point is the temperature at which particles of matter have their minimum motion and can become no colder or minimum energy. Because it is absolute, a thermodynamic temperature reading is not followed by a degree symbol. We will explore more about thermodynamics in our next chapter. So, absolute temperature measure using the Kelvin scale. State an ideal gas equation. It is PV equals to nRT. P is pressure, V is volume, N is number of moles of the gas, R is molar gas constant, and T is absolute temperature. Number of moles of the gas also can be written in this form, where small letter m is mass of gas, capital letter M is molar mass of gas, capital letter N is number of gas molecules, and N is Avogadro number. Please take note, Avogadro number, it is not Jangan Gado. Hence, the ideal gas equation can also be written as this or in this form. So we have three options, option 1, option 2, and option 3 to state an ideal gas equation. shows that the molar gas constant R is equals to 8.31 joule per Kelvin per mole. For 1 mole of gas at standard temperature and pressure, or we call it STP, 273 Kelvin and 101.3 kilopascal, the volume is 22.4 dm cube or 22.4 times 10 to power of negative 3 meter cube. From an ideal gas equation PV equals to nRT, we can define R, so-called molar gas constant, by substitute all the values accordingly into this formula. For N is 1 mole, we can find the molar gas constant R, which is equals to 8.31 joule per Kelvin per mole. The unit for molar gas constant R, by referring to this formula again, where PV is work done is about joule, N is mole, T is absolute temperature measured in Kelvin. So the unit is about joule per Kelvin per mole. And how about the Boltzmann constant K? Show that the Boltzmann constant K is about 1.38 times 10 to power of negative 23 joule per Kelvin. By using the formula of K equals to R over Na, R is molar gas constant, which is 8.31 joule per Kelvin, and Avogadro is 6.02 times 10 to power of 23 per mole. When we divide R into Na, we will get the value for the Boltzmann constant K, which is equals to 1.38 times 10 to power of negative 23 joule per Kelvin. Simple like a bubble without giving you any trouble. Thank you for watching this video. Thanks a lot and thank you to the Lord.